Hi guys, got a calculus question for you today. The question says we're going to use first principles to determine the derivative of 5x squared with respect to x. Now using first principles is basically what that means is using the definition of a derivative, which is this formula which I've included here. This wasn't with the question, you probably need to commit this to memory. So basically what we have to do is we take the average rate of change from f of x plus h to f of x, and then we make those 2 points, we make the difference between them get closer and closer to 0 until we get to the instantaneous rate of change. But I'm not going to go through like the mechanics of this, I'm just going to go through solving this problem. If you need the mechanics video, I've probably included that somewhere else in the playlist. So basically what we have here is we have f of x is equal to 5x squared. So let's break this down. We're going to have f of x plus h. And what that's going to be equal to, it's just f of x, which is this, but we replace the x with an x plus h. So it'll be 5. Rather than writing x, we write x plus h squared. So that's what we're going to sub in for x plus h. So let's go about solving this. So this is going to be equal to the limit as h approaches 0 of, I like to put a bracket just to separate it from myself, function of x plus h, which is this, minus f of x, which is just this, all divided by h. Now, most of the process of calculating these first principles derivatives is exactly the same. So what we're going to do now is we're going to multiply out that bracket there. Now we have to make sure when we do this expansion that this is going to be so that is the expansion of this one. So let's write that down, and we can even multiply the 5 into the bracket at the same time. So this is going to be the limit as h approaches 0 of 5x squared plus 10xh plus 5h squared. Now I'm just going to get rid of this so I've got some space. Cool. Then we're going to minus away 5x squared, and all of that is divided by h. Now, pretty easy to see that 5x squared minus 5x squared, that will cancel itself out. And we're then left with, this is equal to the limit as h approaches 0 of 10xh minus 5h squared, all divided by h. Now we need to cancel out this. What will happen now is we need to factorize the top or the numerator by h so we can in effect cancel out the denominator, so we can make some sense of this as h approaches 0. So this is going to be equal to the limit as h approaches 0 of h outside of 10x minus 5h. Sorry about my handwriting. All divided by h. Now we can see that we've got these two h's which we can then cancel out, and that leaves us with the limit as h approaches 0 of 10x minus 5h. So what we can do then is we can just write a statement. We can say that as h approaches 0, comma, 10x minus 5h approaches 10x. Therefore, f prime of x is going to equal to 10x. So, you can see that it's not a very complicated method. We literally just substitute in our x plus h. We substitute in all the rest of the values that we need in this definition of a derivative. We then, from there, all the way to the end, it's just a matter of making sure your algebra is correct and that you expand out brackets correctly. Make sure you need to cancel out the denominator in most cases because, you need to cancel out the denominator because if you send h to 0 with a denominator of h, this will approach a solution that won't make any sense. So basically what we do is we get there, we cancel out our denominator, we are left with a function like this. As h tends to 0, we then can tend to our derivative. So this is our rate of change function for the function 5x squared using first principles. So I hope that video helped, and I'll see you again next time.